Hello everyone, welcome back to the channel. Today we'll solve the third problem of weekly contest 388 of Leetcode, which was conducted on March 10th. It's a medium problem. While reading the problem, it might seem a little bit overwhelming, which is totally understandable. What they're asking is, uh, we have an array of strings, right? And for each string, we have to return the smallest substring from that string which does not occur in any other strings in the array, right? If multiple things exist, we have to give the lexicographically smallest, right? So, for example, in this, the substring AB of CAB is not occurring in any other strings of the array. Similarly, in the third string, we have a substring BA which does not occur in any other strings as substring. If there is no such thing, we can simply give uh, empty strings. Say, for example, here A is substring in these two, AD is substring in this one, D is also a substring in this one. We return empty string as there is no answer, right? But see the constraints. Constraint is very small. Maximum length of a string is 20 and n is 100. And based on this constraint, I know even brute force approaches are working. Even what we are going to do is brute force, but we are going to use a try, right? First, I would like to say why I got the idea of using try. It was based on two factors. First one is this one, which is clearly hinting tries need to be used because it consists of only lowercase English letters. So the entire range is only 26 alphabets, and mostly it is clearly hinting that we need try. Though this is not that much trivial, but this is one of a small clue to know there might be a need of a try in this problem. And second thing is, I have solved a problem for finding a number of unique strings in a substring. Uh, there is a very efficient approach, but the best approach was big O of n square, which we do using try. I seriously recommend trying to solve that problem. The problem is find number of unique substrings in a string, right? Try to solve it later. Okay. So then what we need to think is we always need to give the smallest possible substring, and there should be a mechanism to check whether this substring exists in any other string, right? So what we will do is we'll create a separate try for each string, and in each string we will insert all the suffixes, which is called as suffix tree. Uh, so how the try would look for the string CAB would is right to explain it here. For CAB, the try would be initially say there was this node. Now this node in the level 2 will have C, A, B as one thing, and A would be there, B would be there, and so this is how the tree will look. In the first level, C from the root node, there will be there will three childs will be there, C, A, B, and C will have a child A and B. A will have a child B, and also B doesn't have any other children. Similarly, for BA, AD, the try would look like this. So what is the advantage of having something like this is, say now we want to check whether say A was a substring of this thing. We just need to check, start from the root node and try to traverse A. If we are able to traverse without any null nodes, then it means A is a substring of CAB. Similarly, if we want to check whether AD is a substring, again we start from root node, we traverse to A, and from A there is only B. D doesn't exist, which means AD is not a substring of CAB, right? Uh, Similarly, the try for BAD would be BAD and AD and D, right? If you want to check whether AD is a substring of this, uh, so from here we go to A, and from A D exists, so we are able to go to D, which means AD is a substring of this. So this is a very clear and easy way. So advantage of try is we are able to check whether a given string is part of that string, whether it's a substring of this string inserted in this try very easily, right? So this is the goal. Now what we do is we create n tries, okay, for each string, and we iterate through it. First, we will define the try. I have a very makeshift way of defining try for solving in contest, so I will do the same. You can maybe follow mine or use a standard try definition, right? So, right, child of we need 26 alphabets, and bool is end. Right. Now what we do is we'll write the insert function. So as we are inserting CAB, then AB like that, we'll write the handy function with the start variable. Okay. So the start variable indicates from which part of that string we are inserting. So node star current equal to this is standard definition. You can check anywhere else also. Now we iterate to the string from this start variable. And if that node is not existing, we create a node. And now we traverse to that node, right? This isn't variable is not necessary, but just to follow proper guidelines, We'll update the distance variable also to 1, right? Now we'll write a check function to check whether a given string is there in the uh, try. The return will be bool. Why I am using reference variable is it won't create new memory, and it will reference so that the memory will be as small as possible and not too much copying time would be there. So it's not necessary for strings, but I like to follow it. Mostly in competitive coding, it's better to follow that. And similarly, the start variable and the length. There we are checking whether some string is existing in this. Since we are mostly checking substrings, let's say start is the starting point of the substring in the string, and length is the length of the substring. So like that, right? We have to. So this function, what it does is, it checks whether the substring from this index of length this in this string, whether it exists in this try or not, right? So a substring starting at index start from this string of length this, whether it exists in this try or not is what this function will check. So again, the code is almost same. So let's copy it. So if this is null, I will return false, meaning that this substring is not part of this try. Otherwise, I will traverse. In the end, I will return true. So here, as if you want to check whether AD exists, when we go to A, it's fine. From A, we are not able to go to D. So there, this the check function would have returned false, right? Uh, Say if we were in this, if we go for check AD from A, from this it will go to A, from this it will go to D, and there it will stop and return true. So that was this function does. Both work in big O of N. Cool. So yeah, now we will create a vector of this tries rows, and the size will be same as size of the array. Now for each array, let's go in normalization way. Let the initially all the roots be null. We'll create new node here. Uh, Roots of I equal to new, right? And now for int j equal to 0, j less than. Now we are iterating through the indices of that string. And as I said, we will insert this try, newly formed try, the string through all the indices. So j for string CAB, initially j would be 0, so CAB would be inserted. Then j would become 1, then AB would be inserted, then j will become 2, then B would be inserted. Similarly, BAD, then AD will be inserted, then D would be inserted. So that's what this function does, right? This is the start as in our function. Next, so we have our try ready. Now we have to do the check operation. So now what we'll do is, now we'll create an answer string array. Get answer of array dot size of, that initially it be empty string, right? For int I equal to 0, less than ar dot size of I plus plus I plus plus. what we do is, hmm, so we the expectation is the smallest substring, right? So we'll iterate through length from 1, and length can be maximum the length of the substring, length of the string itself. Now for each smallest length, we will check for all the substrings of this length from the string. Okay, so for int j equal to 0, j less than j plus length less than or equal to ar of I dot. So we are taking all the substrings of that particular length, right? So if length was 1, uh, in this case, first A would be there, then B would be there, then C would be there. So 0, 1, and 2. Length is 3, so 0 plus length 1, 2, 3, right? Uh, so we iterate that way, and now we have found the substring. Now we have to check whether this substring is not existing in all other tries. So for int say g equal to 0, g less than size of g plus plus, right? If g not equal to j, sorry, I, because we shouldn't check in that try belonging to that substring itself. And this check function will return, should return false, right? In case if it returns true, uh, yeah, we'll check in that particular try. This string, the starting point would be j, and it will be length. If this returns true, if this returns false, it's not an issue. But if this function is returning true, then it means that substring is part of this try, right? Which is not intended. So we will have a flag variable here. This let the flag be true. This flag is to check whether this particular substring is not part of any other try or not. So we'll make this false and break it. The flag was true here. What it means is the substring from index j of this length is not part of any other trace. If it was part of any other trace, this flag would have become false. So uh, if this res length, uh, if res is equal to this empty string, or since we need lexicographically smallest, even if we have already got an answer, but this answer is greater than the like let the new string be string x equal to ar of I dot sub str of j comma len, right? This is the substring which is not part of any other try. If it was part, this flag would have become false, right? So now what we do, if this string x, if the result variable for this particular string which was empty, if it's still empty or it is having a value which is lexicographically small, larger, we just uh, remap res value as this x, right? And okay, now we need shortest substring, right? That is the first condition. Next is lexicographically smallest. So within a particular length, we have to choose the lexicographically smallest, which we are doing here. Say for this particular length, we have got a res value, which is not an empty string. Then we no need to check for the lengths greater than that. So what we'll do, if res dot length of is greater than 0, we break here because we got a substring whose length is at least 1, which is not part of any other tries, right? So we break it here, and answer of I will have this res. If we would have not found any other value, res would have been empty string and it would be empty, right? And after going through this iteration, we will return res. Let's try to check the two easy examples in this logic. Okay, we have got some error. I'm sorry. I should have written answer. Hmm. Yeah. We have to check from this start variable with this length s, right? So this should be start plus length. So basically this function checks from the start index, length characters, length number of characters, and checks whether it's part of the try or not. So that was a small mistake. Yeah. So it seems to works here. Let's estimate the time complexity before submitting. So this one, uh, this operation, the time complexity is big O of, so it goes to array dot size of, so n, and this insertion operation, uh, we are doing how many times? Length times, and each insertion operation will be of time complexity the same as length. So this is big O of nl square, so which is equal to here 100 into 20 20 400. So 40,000, which is fine. And this function, which has like four for loops, right? uh, yeah. So this for loop goes through n. So we go of n times. This for loop goes through the length of array, so which is L times. Again, this for loop goes through the length of array, so that is also L times 1. Yeah, we finish this one, we finish this one, this finish one. And again, we iterate through all arrays, so that is n. And this check function. Check function also is as the biggest complexity as the length of the array. So maximum we can iterate to length. So yeah, into yeah. So we go nl power 3, which is equal to we go sorry n power 2 and l power 3, right? Power 2 and l 3. So 100 into 100, 10 power 4, and 20 into 20 into 20, which is 8 into 10 power 3. So in the worst case, it would be 8 into 10 power 7, which is within expected. Until you don't reach 10 power 9, it is fine. So I guess this works, and the time complexity is within constraints. Let's try to submit it. Yeah, and as you can see, this is one of the fastest approach this question as of now. I hope this helps you to do a quite quick brush up. We create vectors for the tries. Each string is having a stripe, right? Each string is having a try, and we insert all the suffixes of each string into its try. Suffixes in the sense CAB, AB, and B for CAB, right? After that, for each element in the array, we iterate from the length 1 to the entire string length, and we check all the substrings of that length from this array, whether it's part of all other tries in the array. If it's not part of any other try, which means it is uniquely present only in this string, so we save it. And if we find another string of same length but lexicographically smaller, also we save it. And after we find it, we return the answer array, right? So that's how it works. Time complexity is n square L cube. Worst case, it's 8 into 10% for the constraints. Thank you. Hi guys, this is a slight update and the improvement from the earlier solution. Uh, Instead of having this is and, what I'm thinking is we will have an unordered set to store the index of the element being inserted, and we'll have only one try. Say for this example, what we'll do is instead of these things, when we insert this CAB, we will have CAB and the index is 0, right? 0. That's it. index 0, index 0, index 0. So after inserting CAB, the try will be like this, right? Now we'll insert AD like this. Okay. So after inserting AD, it will be becoming like this. And now we'll insert BAD. So when we insert BAD, it will become like this. So after first we'll insert CAB, AB and B, and we'll insert AD, so A and D, and we'll insert D, right? So D comma 1. Okay. Now BAD. So we'll insert B, A comma 2, then A comma 2 in the try, and D comma 2. Next AD. So this will get updated. Now D. So this will get updated. Next C. So C is here result. So C will get updated like this. Sorry, 3. Yeah. So what is the advantage of having a single try is the complexity is going to reduce. I hope you understand how this data structure is defined. Each that try has also remembers its children and also all the whose substrings indices of the strings whose substrings ended here. So C is storing information 0, 3 because string CAB and string C have substring C. You can see 0 and 3 has substring C. CA has 0, which means CA is substring of uh, element in the array 0. So CA, CAB, CAB. You can see AD is in 1 and 2, which means AD is there in 1, right? And 2. Similarly, BAD is 2, so BAD is there only in 2. C is there in both. So so using a single try, we are able to manage it. How we will check it? Here for AB, you can see A and B. AB is here. So when we traverse through the try to AB, only one index should be there. Then only it belongs to one string in the array. Otherwise, it is belonging to multiple. See, AD that belongs to two strings, so it is having two elements. So using that, we can check whether that is uniquely present in one string in the array or in multiple strings of the array. Okay. So we'll modify the function accordingly. To remember the indices, we will have another parameter, and this won't be there, and we will insert here. After every transition, we will insert the index, right? Here also, how we check is this checking condition remains same. So it retains the substring won't exist if there is no node at all, right? But this return true statement won't be just this. Another condition is if this current S should have only one element. So as we are iterating through this, if its size is greater than 1, then we have to return false. Otherwise, we can return true, right? As you can see, if it's 1, it's true. Otherwise, it's false, right? Mm. So now, instead of creating multiple nodes, we'll have only one try. We'll name it as root. That's it. And every insert operation, this will be done in the root in the additional parameter, which is the index of the string we are inserting, which is I, right? Ith string only we are inserting, right? So we are giving that index. The time complexity here does won't change. It is n into L only, right? Makes sense. Now here, how we are saving time is this iteration. For each try we were iterating. Instead of this, we will just do a single check. No need of all these statements. So for each string, that's it. So what we do is for each string, we iterate from small length as small as 1 to the length of that string, and we create all possible substrings here, and we check whether this substring is there in the try. If it's there, it will be there because we have inserted all the substrings into the try. But if it's there at the last, after the transitioning to the try till the end, we are checking whether the size is one or greater than 1. It will be 1. It shouldn't be greater than 1. If it's greater than 1, then two substrings from two different elements of the array is there, which is same. Then it is not unique, right? So that check condition it's doing. So by doing this, we are checking that, right? And all other conditions remain same. We are saving this n iteration by not doing it. So it is NLQ. So the time complexity would drastically decrease to 8 into 10 power 5. So that's how we do it here. This is another elegant approach. If you improve, the previous solution was very good. If you improve from that solution to this in an interview, I can guarantee you like a success in that interview. So that is it. I hope this idea helps. I will link the solution to this in the description so that you can understand this code better by going through it again if you are spooked by seeing it changing very quickly. So thank you again and hope this helps you. Bye.